The science of friction and lubrication. Every time you walk, drive, or even use a pen, you are dealing with friction. It's the invisible force that resists motion and the reason we need lubrication to keep the world moving smoothly. Let's break down the fascinating engineering behind friction and lubrication. What is friction? Friction is the resisting force that occurs when two surfaces move or try to move across each other. At first glance, surfaces look smooth, but under a microscope, they are full of tiny peaks and valleys called asperities. When these rough spots rub together, they interlock and resist motion. That's friction in action, sometimes useful, sometimes a problem. The two faces of friction. Friction isn't always bad. In fact, we rely on it every day. Good friction helps you walk without slipping, let your car tires grip the road, allows brakes to stop a moving vehicle. Bad friction wastes energy in engines and machines, causes wear and tear on parts, generates unwanted heat. Engineering is about finding the right balance. The science behind it. Friction depends on two main factors. Number one, normal force, that is how hard the surfaces are pressed together. Number two, coefficient of friction, a property of the materials in contact. The basic relationship is force equals mu n, that's coefficient of friction multiplied by normal force. That's the frictional force equation. Simple but fundamental to mechanical design. There are also two main types. We have static and kinetic friction. Static friction, when objects are at rest, they are harder to overcome. Kinetic friction, when objects are already moving. Where lubrication comes in. Lubrication is how engineers control friction. A lubricant, usually oil, grease, or even gas, forms a thin film between surfaces. This film separates the rough contact points, reducing the friction and wear dramatically. Instead of metal rubbing on metal, you get a smooth glide with minimal resistance. The different lubrication regimes. Engineers classify lubrication into three regimes. Hydrodynamic lubrication, that is a full fluid film completely separates surfaces. Common in engines and turbines, friction is extremely low. We have boundary lubrication. Only a thin molecular layer of lubricant remains, seen during startup or slow movement. We have mixed lubrication, a transition zone where both contact and fluid film coexist. Understanding these regimes helps engineers choose the right lubricant and surface finish for any machine. Types of lubricants. Lubricants come in many forms. We have liquid oils for engines, turbines, and hydraulic systems. We have greases for bearings, gears, and places where oil can't be contained. We have solid lubricants like graphite or molybdenum disulfide used in space or vacuum environments. Each type serves a specific purpose depending on temperature, speed, and load. The engineering behind lubrication design. Lubrication systems aren't just about reducing friction, they also help carry away heat, prevent corrosion, reduce vibration, extend equipment life. That's why modern machines include oil pumps, filters, and sensors to maintain the perfect lubrication conditions. Even a tiny failure in lubrication can cause massive mechanical damage. Friction, tribology and innovation. The study of friction, wear and lubrication is known as tribology, a key field in mechanical engineering. Tribologists design advanced coatings, nano-lubricants, and surface treatment that make machines more efficient and longer lasting. From jet engines to electric vehicles, friction control is central to energy efficiency and sustainability. In conclusion, friction may seem simple, but it's one of the most powerful forces shaping the modern world. It can stop a car or destroy an engine, but thanks to the science of lubrication, engineers have learned not to eliminate friction, but to master it. Like, share, and subscribe for more engineering insights made simple. Thank you very much.